There are a lot of advantages, and in my opinion, this is the most important. Large amounts of objects can be treated quickly and in the final package. Because this treatment should be seen as a salvation treatment. Of course, we have some disadvantages. It's no preventive effect. It's not a repellent. I saw that Ramsina put this question. No, it will not protect after the treatment the objects that can be recontaminated. There are possible side effects for certain materials like gemstones or sensitive materials like paper. And in this case, the repeated treatments must be carefully considered. But in a case like that, imagine that you have 9 tons of documents in a very bad condition. A quick treatment should be used. And we, in our irradiator, which is not a large-scale irradiator, we can process all this quantity in a couple of days. This is a top view of our irradiator. These are irradiation containers. Documents or books can be processed using these containers, but we also have this area that can be used for large objects like sculptures, furniture, and so on. There are a lot of papers published in the last 2 decades regarding the effects of ionizing radiation on paper. Most of them agree that at dose of 10 kilogray, no, the macro properties are not significantly affected, meaning by this color or mechanical properties. However, we have a problem with free radicals. Some of them can be very stable, especially for paper which contain cellulose of high degree of crystallinity. They can last for months or years. And most of the studies use thermal treatment just to have them decayed, which is not a good idea in my opinion, because thermal treatment will increase their mobility. They will not combine locally, but can migrate and change the properties of material. So this study has the main point to study the temperature kinetic, room temperature kinetic of radiation-induced free radicals in parallel with some macro properties. Sorry. The work was carried out under IAEA Coordinated Research Project developing radiation treatment methodologies and new resin formulations for consolidation and preservation of archive materials and cultural heritage artifacts. It was finished last year. We used 5 types of paper, Wadmore filter paper as a reference, newsprint paper, office or copy paper, and paper from 2 old books. They were irradiated at 10 kilogray in average. And for free radicals, we use electron paramagnetic resonance spectroscopy, which is the only method to directly detect free radicals. Colorimetry, of course, by C-Lab, color space. And also we perform some mechanical tests at certain moments after irradiation. Now, this is Watman paper. This is the native signal, nothing special here. And the irradiation signal, which is very specific to irradiation, this kind of signal can't be obtained by any other methods, being it mechanical or physical, only by ionizing radiation. It's a very well-known signal. It's composed, it's overlapping signals of a central one, non-specific, 3 specific, this one, and this one, and a duplet one. I'm not going into the details, but this duplet one appears only within high crystallinity cellulose. Now, the kinetic over time, you can see in, let's say, 1 year, most of the radicals are recombined. Of course, this is that doublet which still remains, but its percent is very low. Regarding the color, you can see there are both of the samples, non-irradiated one and irradiated one, fluctuates around the reference values, nothing special. There is a small decrease in the, let's say, green. A negative value means green, a positive one means red for A star coordinate. But it's very low if you look at the scale, half of unit. And here, the yellowing process. Both the samples are, became yellower. The non-irradiated one and also the irradiated one. What does it mean in total color differences? One unit means the color difference is just perceptible for a normal eye. If this model, exponential model, is correct in a long time, if you look at the saturation values, there will be a small differences between them, but about 1 unit. So in the years, the differences between non-irradiated and irradiated one will be insignificant. We also perform mechanical tests at 5 months after, immediately after irradiation, 5 months and 2 years. They're almost coincident in the uncertainties. This is forced break in the machine direction. This is forced break in the cross direction. Garumani is a book with high quality paper because Omen Höller was Switzerland ambassador of Switzerland in Romania between the two grand wars, and was a good friend of our King Ferdinand I. And you can see the quality of paper looking at this EPR spectrum is almost identical with that pure cellulose. However, in 2.5 years, it decreased at that level. Look at the amplification of the spectrum. Of course, we can't perform mechanical tests on this, only color measurements. You can see the decrease of the signal, EPR signal. And for both samples, non-irradiated and irradiated one, they are following the same directions. A little trend to a redder shadow. And in the case of yellow, a small decrease in the yellow value. But this is in 4 years, so nothing special. This book has a low quality of paper and it's already degraded because it's very old and was kept in not so good conditions. You can see the APR spectrum, it's very weak. This specific one decays quickly. I put here only the yellow value. It's a strong decrease immediately after irradiation. And after that, a small increase because maybe the book wasn't open for many years. Some oxygens entered and react, but nothing special. And also in the total color differences, this is the limit of observability. Newsprint paper, of course, is a low quality paper, only the signal can be seen here. Decays quickly. Lightness, nothing special. You can see here that there is a trend to become red. This is, let's say, green, but of course it's a very small value. And it's increasing to red for both samples. Also, in this case, you can see the yellowing effect. And strange enough, for the irradiated one, the saturation value is lower. And you can see also in this total color differences in time, the irradiated one will be less yellow than non-irradiated one. Strange, isn't it? Mechanical properties are almost coincident within uncertainty limits. You can see here after 2 years, nothing special. Office paper, the EPR signal is complicated by this central very strong signal. This is specific to carbonates. Actually, the calcium carbonate is a common filler in office paper. This is very stable, unfortunately, and we can't separate it. The operativity is very, very strong, and we need higher bands to separate it. But this is not the point, just to have a broad idea of the kinetic of free radicals. You can see here, but still remain this central signal. Now, there is an increase in, let's say, red value of the color for both samples, non-irradiated and irradiated one. And this is an increase in B star value, meaning that is less blue. Because in office paper, they also use some brightening agents to give it a, let's say, fresher look, like snow. But it's the same for both kind of samples. Now, the total color differences in time, you can see it will be the same. Regarding the mechanical tests, in the machine direction, they are almost coincident. But yes, in the cross direction, there is a clear differences after 2 years, about 20% between unirradiated and irradiated one. Okay, maybe 20% looks very much, but for this kind of paper, I don't think it's so important because it is used only for, printing documents. Information is not an important book or something. In conclusions, the most important is that no significant post-irradiation effect was recorded for naturally aged paper irradiated at 10 kilogray. Of course, we have this difference in the cross-machine direction for office paper, but I don't think it's an impediment to irradiate documents printed on office paper. That's all. Thank you. Thank you for your attention.